Okay, so we're gonna talk. This is the second video, or whatever it ends up being, video on the frame fixture stuff. And I had intended to open this up in the last video, but neglected to because I'm winging it. Um, it's well, we can use the bike CAD to build a bike. Um, for your fairly traditional commodity level type bikes or classic bikes, um, those aren't going to be too tough to work from a basic 2D print for. The problem starts, especially in the modern era, where we're talking about a lot of 3D printing and odd shapes of things compared to what has classically been done. The when old folks talk about level top tubes had nothing to do with the bicycle. They had everything to do with manufacturing and how to have an economical set of lugs that would work in various frame sizes, and keeping the top tube level helped with that and generally made it so that you didn't have to do much work on the factory end. But everything gets crazy in the modern era, especially with welded bikes or fillet braced bikes. And we have to meet up with some various things, especially mountain bikes. So, yeah, if you're doing sweet fixies, then you don't have much hard work, or even classic road. There's not a lot of hard work, but we start getting into very high clearance situations here in that seat stay yoke, where I'm trying to make a lot of room up here and minimize the space it takes up, but I need to clear the tire over here. And, same down here, I need to clear the tire, but of course we have a chain ring and we need a little space for the chain, and crank. It's like, why do we have that S-bend type thing? We have a crank out here that needs to clear. And so we end up with these rear ends that are pretty funky. Um, Front ends are pretty funky too in a modern bike, where you can see this is an all-road bike, nothing too extreme in my world. And we have this real offsetting intersection at the down tube type thing. Um, Previously, I'd done bent tubes, and that would bring that tube back into the bottom, the crank shell. Um, but we're doing this now to improve even more, or get even more dropper insertion space. And we have a very small head tube. This is a modular head tube with various parts there, so that we got a top cap welded in. It's kind of Yoetti style in terms of the construction, modern Yoetti. And into an IS type lower. So we have some trickier situations, but nothing's too different from a frame building perspective. We're going to put it on there, and we want everything, the center line of the hub and the center line of the bottom bracket and the center line of the head tube and the seat tube all to be in plane. That is the big goal. And that's our goal. And this is a tricky one when it comes to bike design, because we strive for that. People talk about the perfectly aligned bike and everything like that. And it's like, that's great. The bike is in perfect alignment until you push down on the pedals. And at that instant, the bike is no longer aligned. So we have a lot of myths that are out there regarding what is important on a bike. And certainly we want it to be in plane. We want it to be centered and everything like that, so that on average, as that swinging udder goes back and forth, we're in general over the center, especially with long seat projections like way up here. If the seat tube is cocked weird, you're going to end up with a weird saddle position always, regardless of the sway in the bike. Um, but especially again with the mountain bikes, this clearance issue becomes very important. If that tire, like we're managing a lot of things. Here I've got a Q150 crank and I'm trying to run 2.3 tires and large chain rings. This goes up to 40 tooth on the clearance of that chainring. We don't have a, and then my legs, I have big fat legs. That's one of the reasons I have all this clearance. Um, we we're cutting it really close on a high-end bike, or a high performance bike, I should say. It's like we're really trying to get the most that we possibly can in the tiniest space that we can, and any deviation can cause real problems, as anybody who's built a bicycle frame knows. So we're gonna we need to be able to hold tubes. We need to hold them solidly. It's good to have 3D models if you're doing wacky bikes or differing bikes, because just figuring out some of this stuff, I have a lot of, the math, if we have a master frame equation thing. So these are all equations driving this frame. It gets built numerically from those, uh, and then it has independent part files that are needed for production. But you can see that we have driving parameters that lead to driven parameters. Um, and and the same thing happens for the frame. I mean, the fixture, where we're going to have driving parameters that lead to driven parameters, and we need to make sure we're focusing on the right ones. Um, let's see, what else do we need to talk about over here? Oh, we also have some other cool stuff that happened back here. We're in the world of the UDH dropout, which means we have what is it, a 7 millimeter offset on this side of that hanger from where our hub end is, and various clearances. We also have, when we put the bike together, we have what's called the clocking of the hanger. Here, I think it's this one. Let's see, which button does what? Okay, anyway, that's the other one. Let's go. Okay, there. Okay, so one thing a lot of people kind of ghost on is clocking of the hanger. UDH defines the location of the clock fairly well, which is nice. Earlier or other type of dropouts, you have to do a little bit more work. And that means that, you know, if you drew a perpendicular line from the bottom bracket to the hub axle, or a line from those two, and then a perpendicular line from that, I believe the SRAM spec is 8 to 10 millimeters. Rearward, this hole should be for mounting the derailleur. And that's something more people should take a look at and be aware of. And we want to think about that when it's on the fixture. That's definitely something that happens there. Um, on the other side, while this is a 3D printed dropout with provisions for caliper mounting on it, um, some amount of brake fixturing can be done while the bike is in the fixture. So having some ease in terms of that while it's fixtured up is very helpful, and working with sub-assemblies can help. What else do we need to know here? Uh, I don't know. I mean, there's other things I can talk about, fork fixturing and handlebar fixturing, when we get into fabricating those types of things, but those are a little different. Okay, so why don't we'll quit this video and we'll go into Cyberdyne on the next one, because we love the Cyberdyne. Okay, so here we go, and